Partitioning, and in this lecture we will discuss the method of concept of BSPT, that is binary space partitioning tree. So actually in game design, the very time consuming process is the rendering process. Actually rendering is a process where a scene is drawn in the presence of light and camera. Okay, so and this scene construction is done in every frame. So we can say that rendering, if a rendering process will be time consuming, so our game will be very slow, because in every frame, if rendering will take more time, then overall it will affect the uh, speed of the game. Okay, so for we have to make our rendering process fast. Okay, so for that there must be such kind of method by which we can judge that which object which is available in the scene will be rendered first. Okay, so if we will render only those objects which are uh, visible in the scene, then definitely by this way we can enhance the speed, we can increase the speed of the rendering process. So binary space partitioning tree is a method by which we can know the order of rendering the objects. Okay, so unlike Pento's algorithm, which is uh, based on the concept of back to front painting, hmm, where lots of code drawing was done. Here in BSPT, we draw the scene from front to back. Okay, so here we reduce the overdrawing phenomenon, and in case of BSPT, we save our time, and as well as we can increase the speed of the rendering. So how we can achieve this? Suppose uh, actually this BSPT is applicable or useful in those scenarios where our view reference point is changing very frequently. Okay, so suppose there is a game scene and there are few game objects like so suppose there are three game objects. This is A, this is B, and this game object is C. Okay, and suppose here is our camera. Okay, so we can say that our view reference point is available here. So now how we can decide that which game object will be rendered first? So here we will apply Bspt method. So in case of Bspt method, first of all we randomly draw a plane. Suppose I'm drawing a plane P1. So here we can see that this plane is dividing the scene into two parts. One is this part and the other one is this part. Okay, so if we will see that this plane P1 has two parts, one is front with respect to the camera and another one is back with respect to the camera. So with respect to camera, this portion this portion will be front and this portion will be back. So we can see that here one object A1 will be front of P1, and the partial object, here we can see that this plane is dividing the game object C into two parts. So suppose this part is C1 and this part is C1. So here we can see that the front of P1 is A and C1, and back of P1 is B and C. Okay. Now again if I divide this scene with a different plane, that is P2, so here we can see that uh, this particular portion will be front with respect to this viewpoint or camera, and this portion will be back. Okay, so with respect to P2, again there will be two parts. One is front, another one is back. So front will be C1 and C2. Okay, and back will be A and B. Okay, so now uh, based on this information, we have to create a tree that is basically binary tree. So as we know that in binary tree, so there will be at most two child for every node. Okay, so the root node will be our first plane P1. Now the branches, there will be two branches. One branch will be front, another one branch will be back. Okay, so always left branch will be treated as front, and right branch will be treated as back. Okay, now so here we have to keep in mind one thing, that always the leaf node will be the game objects. Okay, it means that internal node will always be the planes. So here we can see that when P1 is divided into two sub branches, then definitely uh, we will again uh, write the next plane, that is P2. Okay, so now uh, P2 will have again one front and one back branch. Here will always be one front and one back branch. Now it's time to write the game objects based on this information. So here uh, the front of P1, so the front of P1 is A and C1. Okay, again the front of P2, so the front of P2 is C1 and C2. So here in both the cases we can see that the common is C1. Okay, so here we will write C1. Now we have to find out the front of P1, that is A and C1, and back of P2, that is A and B. So we can see that in both the cases A is common. So here we will write A. Okay, now what is the back of P1? That is A and B, sorry, B and C2, and front of P2, that is C1 and C2. So here we can see that C2 is common, so we will write C2. Now back of P1, that is B and C2, and back of uh, P2, that is A and B. So common is B. So now here we can see that we have uh, finally written all the game objects as a leaf node. Okay, so now with respect to this view reference point, this will be the order of rendering the game objects. So first of all C1 will be rendered, after that we can render A, then C2, then B. Okay, so this will be the order of rendering the game objects. Okay, so that's it from this video. In next video we will see another concept of game design.